Welcome to ICSECLASSROOMS Dream Project of hundreds of IITians and school toppers. Project handled by me, SACHIDANANDA, RATH, Faculty of IIT Physics, IIT Mathematics and Speed Maths. Dedicated to the greatest America-born Australian physicist, late Julius Sumner Miller, who taught me the importance of sharing knowledge apart from gaining it, with a view of making conceptually clear education accessible to ICSE students, launching classroom DVDs, the innovative product of its kind for the first time in India. You do not have to worry any further if you get delayed to the class by some time due to some or other reasons and thereby didn't understand the full discussion or didn't understand concepts in a coaching class. Now start learning mathematics anytime, anywhere. Do not have to panic if you didn't understand the basics properly in standard 6th or 7th, as all the basics of standard 6th and 7th are discussed in the DVDs. Introducing classroom DVDs, only trigonometry, quadratic equations and mensuration is given at Rs 2000. Complete ICSE Maths is given at Rs 5000. Covers complete discussion of ICSE Mathematics from Selina Publications book, with last year's questions being discussed. Please log into www.icseclassrooms.com for latest updates. Account details: name Sachidananda RATH, State Bank of India, account number 109180342885, or ICICI Bank, account number 14170150404, or HDFC Bank, account number 0832100001047. Just transfer the amount to any of the bank accounts and give a ring to 09945051713 or 09945422303. Email details of your transaction to sachinrath123@gmail.com. Courier will be sent to you on the same day. You do not have to pay any courier charges. Converting mark-oriented education to knowledge-oriented one. I conclude, maths is easy and enjoyable if learnt in the genuine way. Going with the first discussion, trigonometry. Trigonometry, as such, is quite easy and can be mastered in just 3 to 4 days. Let's go with the basics of trigonometry. We have mainly 3 formulae. That is sin squared theta plus cos squared theta is 1, cosec squared theta minus cot squared theta is 1, and sec squared theta minus tan squared theta is 1. These 2 formulae are easy to remember. For example, sec squared minus tan squared, alphabetically, first s comes, then t, like if I will write a, b, c, d, e, f like that, then first s, then t. So it's, once you remember, sec squared is tan squared. Similarly, cosec and cot, co is same, again s and t. Sin squared plus cos squared is 1, cosec squared minus cot squared is 1, sec squared minus tan squared is 1. Then we have cosec theta is 1 by sin theta, sec theta is 1 by cos theta, tan theta is sin theta by cos theta, cot theta is cos theta by sin theta. With this much, you can solve all problems in trigonometry. So wherever you're finding cosec theta, just write it as 1 by sin theta. Wherever you're finding sec theta, write as 1 by cos theta. Tan theta, write like sin theta by cos theta. And cot theta, write like cos theta by sin theta. With this much, you can solve all problems of exercise 23A from Selina publications. Now let's go with the values of trigonometric functions. Write 0, 1, 2, 3, 4. Divide everything by 4. Now take a square root. 0 by 4. 0 by anything is 0. So 0 by 4 is 0. Square root of 0 is 0. Square root of 1 by 4 is square root of 1 divided by square root of 4. Square root of 1 is 1. Square root of 4 is 2. 2 by 4. Square root of 1 by 2 is square root of 1 divided by square root of 2, which is 1 by square root of 2. Radians root 2. Square root of 3 by 4 is square root of 3 divided by square root of 4, which is square root of 3 divided by 2. Radians root 3. Square root of 4 by 4 is 1. Square root of 1 is 1. Okay. Now let's write here 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. These all are giving me the values of sine, that is sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. Now let's write the same thing in the reverse order, that is 1, then root 3 by 2, then 1 by root 2. I'm writing like this, then 1 by 2, then 0. So 1 I wrote here, root 3 by 2 wrote here, 1 by root 2 in the same position, 1 by 2 here, 0 here. This will give me the values of cos. That is, cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 by 2, cos 90 is 0. Now let's divide this by this, that is 0 by 1. As I told, 0 by anything is 0. This is 0. 1 by 2 divided by root 3 by 2. I can cancel this like this, left with 1 by root 3, or it's like 1 by 2 divided by root 3 by 2 is 1 by 2 into 2 by root 3, which is 1 by root 3. This is 1 by root 3. Now 1 by root 2 divided by 1 by root 2. I'll just give a bracket and I will cancel, because let me say this is x. X by x is 1, or 1 by root 2 divided by 1 by root 2 is equal to 1 by root 2 into root 2 by 1, which gives me 1 by 1, which is 1. So this is 1. Then let's divide root 3 by 2 by 1 by 2. This is root 3 by 1, that is root 3, or root 3 by 2 divided by 1 by 2 is root 3 by 2 into 2 by 1, which is root 3 by 1, that is root 3. Anything by 1 is the same thing. So this I got as root 3. Now 1 by 0, anything by 0 is infinity. Infinity is something which is a very big number, what we can't count. So these all data are giving me the values of tan. That is, tan 0 is 0, tan 30 is 1 by root 3, tan 45 is 1, tan 60 is root 3, tan 90 is infinity. So, if at all you forget how much is sine 60, you can very well get by going with this process. Now, if at all I will ask you how much is cosec 30. Now, in the beginning I told you that cosec theta is 1 by sine theta. So we do not have to remember the table for cosec. Now cosec 30 is 1 by sine 30, and sine 30 is 1 by 2. So this is 1 divided by 1 by 2. This is, this 2 moves up, that is 1 by 1 into 2, which gives me 2 by 1, that is 2. 1 into 2 is 2, divided by 1 is there in its place. Similarly, if I will ask you cosec 45, then this is 1 by sine 45, and sine 45 is 1 by root 2. So this is 1 by root 2, which is root 2. If I will ask you how much is sec 0 degree, so sec theta is 1 by cos theta, so sec 0 is 1 by cos 0, cos 0 is 1, so this is 1 by 1, that is 1. So how much is sec 30 is, it's 1 by cos 30, and cos 30 is root 3 by 2. So this 1 by root 3 by 2, this moves up, this is 2 by root 3, because this is 1 into 2 by root 3, 1 into 2 is 2, root 3 is there in its position. Just one extra thing we will remember here, that is cot theta is 1 by tan theta. This will use while we are getting the values, and we do not need this while we are solving identities of exercise 23a. Anyway, cot 45 is 1 by tan 45. Tan 45 is 1, so this is 1 by 1, that is 1. Similarly, cot 60 is 1 by tan 60. Tan 60 is root 3. So this is 1 by root 3. I'm going with questions from Concise Mathematics by Selina Publications. Going with the first few questions of exercise 23A. Let's go with the first question. Prove the following identities. On left hand side is sec a minus 1 divided by sec a plus 1. Now, as discussed, anywhere we will find sec a, we will write as 1 by cos a. So this becomes 1 by cos a minus 1 divided by 1 by cos a plus 1. Now let's take an LCM of cos a. So this becomes 1 minus cos a. Similarly, this becomes 1 plus cos a divided by cos a. We can very well cancel cos a and cos a. So this becomes 1 minus cos a divided by 1 plus cos a, which was supposed to be proved. This is my right hand side. Therefore, LHS is equal to RHS. Now, if you want to know what happened in this step, this is 1 by cos a minus 1. 1 I can write like 1 by 1, and then I'm taking an LCM. That is, when we have a by b plus c by d, then we'll multiply these two, is b into d, then multiply these two, is a into d, plus multiply these two, that is c into b. If there is a minus sign in place of plus, we will have minus. So here we multiply these two, that is cos a into 1, then 1 into 1 minus 1 into cos a. 1 into 1 is 1 minus 1 into cos a is cos a. Cos a into 1 is cos a. 1 into x is x into 1, that's equal to x. In the next step, these two were getting cancelled because 1 minus cos a divided by cos a divided by 1 plus cos a divided by cos a is equal to 1 minus cos a divided by cos a into cos a divided by 1 plus cos a. This was giving me 1 minus cos a divided by 1 plus cos a. Here we are using a by b divided by c by d is a by b into d by c. Some people insist that trigonometric functions shouldn't be given a cancellation sign, so you can just leave cos a and cos a without giving the cancellation sign, and finally come to 1 minus cos a divided by 1 plus cos a. Question number 2. 1 plus sin a divided by 1 minus sin a equals cosec a plus 1 divided by cosec a minus 1. As we have cosec a on the right side, let's open the right hand side, that is cosec a plus 1 divided by cosec A minus 1. As discussed, wherever we'll find cosec A, we will write that as 1 by sin A. So this is 1 by sin A plus 1 divided by 1 by sin A minus 1. Taking the LCM in the previous, as in the previous case, so it will become sin A 1 plus sin A divided by 1 minus sin A divided by sin A. Let me not cancel sin A and sin A, meaning let me not give cancellation signs. That's equal to 1 plus sin A divided by 1 minus sin A, which is my left hand side. Therefore, RHS equals to LHS. Question number 3. 1 by tan A plus cot A is cos A into sin A. Let's take the LHS as 1 by tan A plus cot A. As discussed, wherever we will find tan A, we will write that as sin A by cos A, and cot A we will write like cos A by sin A. So this 1 by tan A is sin A by cos A, cot A is cos A by sin A. Now let me take LCM over here, that is 1 divided by, this is cos A into sin A, then sin A into sin A is written as sin squared A, plus cos A into cos A is written as cos squared A. This is 1 sin squared A plus cos squared A is 1 divided by cos A into sin A. This is cos A into sin A, which is my RHS. Therefore, LHS equals to RHS. So here, this is 1 divided by 1. Let me say cos A into sin A is x. This becomes 1 into x by 1. Now 1 into x is x, x by 1 is x. Question number 4. Tan A minus cot A equals 1 minus 2 cos squared A divided by sin A into cos A. Let's take the LHS. Tan A minus cot A, so tan A is sin A by cos A minus cos A by sin A. Let's take the LCM, that is cos A into sin A sin A into sin A is sin squared A minus sin in its position, cos A into cos A is cos squared A. Now we have sin squared A plus cos squared A is 1. I'm finding the RHS is having cos squared quantities. Here I've got a sin squared, so sin squared A is 1 minus cos squared A. So this is 1 minus cos squared A minus cos squared A divided by cos A into sin A. This is 1 minus 2 cos squared a divided by cos a into sin a. So 1 minus 2 cos squared a we got. Then he has written like sin a cos a. We have got cos a into sin a, so let's just write exactly like the RHS. So cos a into sin a is sin a cos a. Therefore, LHS is equal to RHS. Question number 5. Sin 4th a minus cos 4th a equals 2 sin squared a minus 1. LHS is sin 4th a minus cos 4th a. Sin 4th a can be written like sin squared a whole squared minus cos squared a whole squared, because when we have x to the power 4, it's basically x squared whole squared. Now this is sin squared a plus cos squared a multiplied by sin squared a minus cos squared a. Using the formula, a squared minus b squared is a plus b into a minus b. Here sin squared a we can take as a, cos squared a we can take as b. So it's given like a squared minus b squared, that is a plus b into a minus b. Now sin squared a plus cos squared a is 1 multiplied by sin squared a minus cos squared a. 1 into anything is the same thing, so this is sin squared a minus cos squared a. In the RHS I am finding sin squared minus 1. So there is no cos squared in this, it's 2 sin squared a minus 1. So I will make this cos squared sin squared. We have sin squared a plus cos squared a is 1. So cos squared a is 1 minus sin squared a. Now this is 1 minus sin squared a, that is sin squared a minus 1 plus sin squared a. Sin squared a plus sin squared a is 2 sin squared a minus 1. Therefore, LHS equals to RHS. For the complete discussion of the exercises, please order DVDs. Thanks for watching.